Okay, let's look at the remaining trig ratios and their graphs. Let's look at cosec x. Now remember, this is 1 by sin x, and the moment you see denominator, it cannot be equal to 0. So we know sin x is equal to 0 when x is equal to 0, pi, 2 pi, and also minus pi, minus 2 pi. Okay, so which means this can be in general written as n pi, where n belongs to integers. Domain of cosec x is x belongs to real numbers and x is not equal to n pi, where n belongs to z, that is integers. Okay, now the range would be what? Okay, let's see what the range would be like. Let's draw the graph first. Cosec x, yes, looks funny kind of graph, right? And let me also include sine, right? You notice whenever sin x is 1, cosec is also 1. Why? Because 1 by 1 is 1. Whenever it is 0, which one? Sin x. Whenever it is 0, you seem to end up with a straight line which is not touched by the graph of cosec x at all, isn't it? So here you have a 0, here you have a 0, again it is not touching it. Now let's actually draw that vertical line, additional vertical lines. X is equal to minus pi. So here if you notice, it keeps going. Even if you go up, after some time it may look as if it is touching the line, but if you zoom in, a gap will appear. So we say that as x comes closer and closer to 0, as x comes closer and closer to 0, pi, 2 pi, 3 pi, minus 2 pi, what happens? Y goes towards plus infinity or minus infinity, right? So the range is y is less than or equal to 1, or y is greater than or equal to, y is less than or equal to minus 1, and y is greater than or equal to 1. That's the range. Okay, now let's very quickly see how cosec 2x, cosec 3x, cosec minus x, cosec square x, and cosec cube x looks like, right? Let's remove this. Let's remove this sin x. Cosec 2x, right? Now can you guess what is happening? The whole thing is getting scrunched up, and I've been using this term in the previous graphing session also for sine, cos and tan. I hope you noticed that when I said 2x, between 0 and pi, cosec x only one graph is there. either on the positive side or on the negative side within the domain of 0 and pi, 0 and minus pi. Only one cosec x graph is there. The moment I say 2x, what happens? I end up with 2. So blue one, see 1 within 0 to pi and 2. So my understanding is if I say 3, there should be 3 of them, right? So let's see. Let's see whether there will be 3 of them. Cosec 3x. Do we have 3? Orange 1, 2 and 3 between 0 and pi. Okay, so let's now look at the next one. What is the next one? Minus x. Cosec minus x. What's happening? Yes, positive is becoming negative. Okay, so which means that this is becoming cosec minus cosec x. Okay, and you can actually do it, solve it algebraically also. Okay, let's look at cosec square x. Cosec square x. Now what's happening? Let's make it disappear. I'll keep. So one thing is very clear. Square means all the negative parts of the graph comes to the positive side. And the graph is becoming a little bit sharper. Let's see what happens when I say to the power of 4. Yes, it's becoming much more sharper. Okay, keep that in mind. Now let's look at cube. Right, back to normal. Cosec kind of graph, and plus it's becoming sharper, right? See, cosec x green is broader graph, whereas cube is much more sharper. It is actually much more sharper than square also. Let me include square also so that you get a feel of it. Cosec square. Yes. Okay. You got the idea. So that is as far as cosec is concerned. Now let's look at the next one. After cosec, let's look at sec x. We know sec x is 1 by cos x. We know it can't be 0, and cos x is 0 when x is equal to not 0, pi by 2. Pi by 2, that is both plus or minus 3 pi by 2 plus or minus 5 pi by 2, and like that. So basically this is odd multiples of pi by 2. So which means domain of sec x is it belongs to real numbers, can be any real number, except that is x can't be equal to 2n plus 1 pi by 2, that is odd multiples of pi by 2, where n belongs to integers. Okay, what about the range? Now range, let's see how the graph will look like. Let's say sec x, right? Looks very similar to cosec x. The only thing is it is shifted, so it corresponds much more closely to cos x, right? So whenever it is 1, this is also 1. But just like in cosec, there seems to be a vertical line where it doesn't touch. The only thing is it is not pi. We know it is pi by 2, right? And minus pi by 2. Basically all the odd multiples. Okay, so range is again y is greater than or equal to 1, or y is less than or equal to 1. Okay, let's very quickly look at sec 2x, sec 3x, sec minus x, sec square x, and sec cube x. Okay, sec 2x, right? The graph has become sharper. See here, this is your sec 2x. It is much more sharper than sec x. Okay, sec 3x. Now this has become much more sharper. Okay, in case of cos sec x, one full graph is there between. Now if I change it to 2x, what happens? There is 1 here, half of it is here, half is here, so you have 2. And if I say 3x, what happens? 1, 2 and 3 graphs. Okay. Now, what happens if I take the negative value? Okay, let's say sec minus x. Right, sec minus x, there is no change. Right, the graph remains as it is, which means sec minus x is equal to sec x. Right, the graph becomes a little bit more sharper than, and of course all the negative values disappear. Let's see what happens with sec cube x. It becomes much more sharper. Yes, and of course the negative side also appears in case of odd number powers. Okay, so let's look at now cot. Let's remove off all these. Okay, let's look at cot. Now remember, cot is nothing but cos x by sin x, which means sin x can't be equal to 0, which means x can't be equal to n pi, where n belongs to integers, right? So the domain of cot is what? Is x belongs to all real numbers, x is not equal to n pi, where n belongs to integers. Okay, what about the range? So let's draw the graph and see cot x, right? So what we require is not pi by 2, we require pi to see the vertical line which is not touched by the graph. It gets very close to it but doesn't actually touch it. Okay, so we can say y is, and normally we write it in the increasing order, so minus infinity is less than or equal to y, which is in turn less than infinity. Goes from minus infinity to infinity. Okay, so let's very quickly look at cot 2x, cot 3x, cot minus x, cot square x, cot cube x. Okay, so first of all, let's remove this tan x. Okay, cot 2x. What happened? Where you were having two graphs, now you have, where you were having one graph, now you are having two graphs, right? Okay, let's see 3. So 3x. Show. Okay, now you are having, where you had one, now you are having three graphs, right? And the curve is becoming narrower. Okay, cot minus x. What happens? Cot minus x becomes cot x, right? Let's hide this. Let's hide this. Let's retain this. Cot minus x becomes, if you notice, negative, right? Becomes the mirror image. So cot minus x is equal to minus cot x. Okay. Let's remove this. Okay. Now let's say cot square x, right? All the negative values have disappeared, or rather the negative side has come to positive side. That's a better way of looking at it. So this was going down. Instead of going down, it is going up. Okay, cot cube x, cot cube x, right? The graph is becoming narrower. Otherwise, there is no change in case of cube. In general, remember, even in algebra, I had mentioned that an equation, an expression of first order is going to be a straight line, right? In case of order 2, it will be a parabola. In case of cubic, it will be a curve like this or like this, whatever. So remember this. And then all the this is not only for square but all even powered orders, and this would be for all odd powered orders, right? The only thing is, depending on the power, they will become narrow or broad. Okay, I think that's enough for today. Bye for now.